Good afternoon, my dear students. In this session, we will start discussing from yesterday's concept called factors affecting acceleration due to gravity, right? So quick recap, we will do that. Then the third factor affecting the acceleration due to gravity will start in this class. So let's start. What was the topic we were discussing is factors affecting acceleration due to gravity value. The first factor we had discussed is the shape of the earth. I hope you could recollect the concept here, shape of the earth related to the radius of the earth. So at the equator, radius of the earth is more. Because of that, acceleration due to gravity at the equatorial region will be less. Okay. So in this, what we had discussed, acceleration due to gravity is inversely proportional to radius here. Okay. Now, the second factor we had already discussed, which is about altitude. Altitude means what? It is height of the body taken from the surface of the earth. In this case, we had discussed about the formula called acceleration due to gravity at some height is equal to G capital M by R plus H whole square. So the same equation we had already learned and modified as acceleration due to gravity at some height is equal to acceleration due to gravity on the surface of the earth into R by R plus H whole square, where R is radius of the earth. Right? Now, the third factor we are discussing in this class is about the depth. What is this? Depth. Depth, I am writing in terms of, I am writing and representing with a symbol called D here. What is this depth? Imagine this is what a surface of the earth. And this is the center of the earth. Alright? You know this is the radius of the earth. So from here to here it is radius of the earth. Now the first case, the mass of the body is kept on the surface. When the body is kept on the surface, distance between the body and the earth. So this is earth, mass of the earth. Understand? So imagine it is the first case. I am writing here, carefully go through it. When the body is kept on the surface, the distance between earth and the body is radius of the earth. Yes or no? The body is kept here and the mass, the center of earth is here. So the distance between these two will be equal to radius of the earth. Now what I am going to do here, from the surface of the earth, I am just taking the body to some depth. Look at here. Imagine this is the point I have brought. So this is the depth D. Now from the surface I have taken the body to some depth. So tell me, what is the final distance between the two bodies here? Tell me. So this is the center of the earth and this is the center of the body. So now I have taken the body to a distance R minus D from the center. I hope you got that. I hope it is clear to you. So what I am going to tell you is the distance, the final distance between the body and the earth is R minus D. Total distance is R. I have just brought to a distance D. So finally, both the bodies are at a distance of R by R minus D from their centers. Okay. Now this is what I am going to write here. So this is the first point. Now when the same body is taken to a depth of D towards what? Towards the center of the earth. Towards the center of the earth, what happened? See the interesting part here. Towards the center of the earth, I have taken the body to a depth d. Now the final distance between the body and the earth is r minus d. So this is an important point. Okay. Now, why we have written this point, and you will understand later. Now, at this depth, you need to find the acceleration due to gravity. I am just giving you direct formula. Once the +1 actual gravitation chapter starts, there you get the derivation of this expression, what we are going to learn now. You see here, acceleration due to gravity at some depth is represented with the symbol g suffix d, which is equal to acceleration due to gravity on the surface of the earth into 1 minus d by r. See here, the very important famous equation for acceleration due to gravity at some depth, which is equal to g suffix e into 1 minus d by r. So some students will be applying square for this, but that's wrong. Why they will be applying square for this? Because acceleration due to gravity at some height, see here there is a square. So you should not get confused in between this. Right? So acceleration due to gravity at some depth is this one. Acceleration due to gravity at some height is this formula. These two formulas are very, very, very important formulas. Okay? Clear? Now, continuation of this, listen to me carefully. The very important objective type question, even for the NEET, JEE, CET exams, I am going to tell you now. See. The body is started from the surface and moving towards the center. You can see here, moving towards the center at some depth we had discussed now. From this depth also, I am doing more further deeper levels into the earth to the center of the earth. You got the point? Now, the body is taken from the surface to the center of the earth. How much depth I have taken from surface to the center of the earth? So, is it equal to radius of the earth? Again, I am telling you, listen to me carefully. So now the body started from the surface and taken to the deeper levels to the center of the earth. So what is the deepest level I have taken from the surface to the center? So that is equal to radius of the earth. That means if you want to find out the acceleration due to gravity at the center of the earth, the depth to be taken, which is equal to r. So I am writing here at center of the earth, acceleration due to gravity, which is equal to acceleration due to gravity on the surface into 1 minus, so what is this depth I have taken? R by r. Are you understanding why I have written here? At the center of the earth means from the surface, how much is the depth you need to take? Which is r. Okay, so this r by r is 1, 1 minus 1 is 0. So acceleration due to gravity at the center, I am writing here, at the center of the earth is equal to 0. When acceleration due to gravity is 0, you know, weight of a body also will be 0. Because of what? As weight is equal to mass into acceleration due to gravity, weight at the center of the earth is equal to mass into acceleration due to gravity at the center of the earth, which is equal to m into 0, and the answer is 0 newtons. Weight of an object at the center of the earth is how much here? It is 0 newtons. That is a very important question. Okay. Clear? Why? Because mass will never change. Mass will never change according to the place or position, but acceleration due to gravity will change according to the place as well as the position. Place means from some height from the surface of, at some height from the surface of the earth it changes. At some depth from the surface of the earth it changes. Okay, so this is how at the center of the earth acceleration due to gravity is 0. We can prove it. But remember, we have not proved this equation as well as this equation. We will be proving in the further classes once gravitation actually first PUC class starts. Okay, now alright, let us solve a simple basic numerical based on this formula. Are you ready? Right? Okay, here, simple basic formula. Simple. What is the basic formula here? The question is, at what height acceleration due to gravity becomes half of its value, at what depth acceleration due to gravity becomes half of its value from the surface of the earth. So listen, so this is what the diagram, a simple diagram I am drawing here. So this is the body of mass m is initially kept here. So this is center. And now the question is, on the surface of the earth acceleration due to gravity is g suffix e. Okay. Now at some depth, you imagine this is the depth. At this depth acceleration due to gravity is half of the acceleration due to gravity on the surface. You can see here at this depth they have clearly given that acceleration due to gravity becomes half of the value on the surface. Now the question is, what is this d, right? Let us apply the same formula. So acceleration due to gravity at some depth is equal to, what's the formula? G suffix e into 1 minus d by r. So what is given here? Acceleration due to gravity at some depth is how much? Half of the value on its surface, which is equal to g suffix e into 1 minus d by r. So this is g suffix e cancel, and here 1 by 2 is equal to 1 minus d by r. So simple, you can see here minus d by r I can take to the other side. So that will become plus d by r, which is equal to, so right hand side 1 I am keeping it as it is, and left hand side 1 by 2 is there, which is plus 1 by 2. If it comes to the other side, so that will be minus 1 by 2. So 1 minus 1 by 2 is 1 by 2. So d by r is equal to 1 by 2. So what I can write? So d is equal to r by 2 at a depth half of the radius of the earth, at a depth which is equal to half of the radius of the earth, the acceleration due to gravity becomes half. Okay, half of the radius of the earth is how much? We know already the radius of the earth is 6,400 kilometers, right? Half of it is how much? So at this depth, which is equal to 3,200 kilometers, so the acceleration due to gravity becomes half of it. Half of it means how much? 9.8 meter per second square on the surface. It will be 4.9. Okay, so 4.9 meter per second square. Understand? In this way, the basic numerical related to the depth. Okay, now come back to the diagram here. Come back to the diagram. Now what we are going to prove, in the beginning of this factors affecting the g value, I had told you one important statement. So what was that? From the surface, if you take the body to the higher altitudes, higher heights, the acceleration due to gravity will decreases. From the surface, if I am taking the body to some deeper levels towards the center of the earth, acceleration due to gravity will decreases. The constant value, that means the value which remains constant on the surface of the earth. So that means a maximum value of acceleration due to gravity on the surface only. From the surface, if you are moving to some height, the g value decreases. From the surface, if you are moving towards the center, your g value decreases. That is what we are going to prove by using these equations. Now, the topic is acceleration due to gravity in terms of density of a planet. Especially in your NEET exam, the questions can be asked based on this topic, because this is the relation between acceleration due to gravity and density of a planet. Imagine, you know the density is the term which is denoted with a symbol called rho. Rho. Some of the students, it may be, for some of the students, it may be a new terminology for you. Rho. So, this is the symbol and this is the pronunciation also I am writing here. R-H-O. So, rho. So, density is equal to mass by volume. So, the mass I am writing it with the symbol M and volume is V. Acceleration due to gravity, we have the symbol called G. G is what? Acceleration due to gravity. So, the complete topic is the relation between acceleration due to gravity and density. It's called rho. That is what the topic we are going to discuss now. So, the acceleration due to gravity in terms of density of a planet. Let us take, this is the planet, the radius of the earth. Imagine the planet is earth, radius of the earth is r. On the surface of the planet, a small body of mass m is kept. And you know the mass of the earth is capital M here. Acceleration due to gravity on the surface of the earth, which is equal to G into M by R square. So, not only on the surface of the earth, on any planet, acceleration due to gravity is Gm by R square, where M is mass of the planet, R is radius of the planet when the body is kept on the surface. Okay. Now, how we can change this equation in terms of density? R. We cannot change this R in terms of density, but we can change the M in terms of density. Because of what? Density is equal to mass by volume, whatever may be the mass. Right here, M is mass of the planet. Density is mass by volume. Mass is equal to volume into density. So this I can write here, capital G into V. V stands for volume into density is rho. V is what? Volume of the planet. Rho is density of the planet, which is divided by R square. Okay. Now, come back. Acceleration due to gravity is capital G into, so what's the volume of this surface here? What is the volume of this? This is the sphere, right? So, any planet you take, they are in the form of, in the shape of sphere. So, spherical planets, all these we are considering. So, volume of a sphere, what is the formula for volume of a sphere? So, volume of a sphere is 4 by 3 pi into r cube, where r is radius of the planet. 4/3 pi r cube is the volume of sphere into its density is rho, which is divided by r square. Carefully you see, r square, here r square cancels and you have in the numerator r. Okay, so acceleration due to gravity is 4 by 3 pi g r rho. This is for the earth. For any other planet you take, for any other planet, acceleration due to gravity in terms of density will be written in this way. Now carefully you see. 4 by 3, this is the final expression. Okay, so there are some constants and there are some variables that are there, but still this is the basic formula of acceleration due to gravity in terms of density. And carefully if you observe here, 4 by 3 is constant, pi is a constant, and g, which is universal gravitational constant. When these three terms are constants, you can write acceleration due to gravity of any planet is directly proportional to the product of radius of the planet and density of the planet. Because radius of the planet is different for each and every planet. You can take from Mercury to the Neptune. Any planet you take, its radius will be different, and any planet you take, its densities also will be different. So that's the reason acceleration due to gravity is directly proportional to product of radius of the planet and density of the planet when the body is kept on the surface. So from this you can write G1 by G2 is equal to R1 by R2 into rho1 by rho2. This is the very important formula while solving the numericals. Got the point? Clear? Sure? Now, how the questions will be asked based on acceleration due to gravity in terms of density of a planet, right? Let's see. See the question here. So let me write the question also here. So the question is, if the radius of the, if the radius of the earth were to increase by a factor of 3. Radius of the earth is increased by a factor 3. Okay. Now, in order to keep small g same by a what factor, density of the earth need to be changed. Got the point? What's the question? The radius of the earth were to increase by a factor of 3. What is that? Given radius is increased by 3 factors. Now, to keep the g value same, so g1 is equal to g2, g is constant. By a what factor, density of the earth need to be changed. Density of the earth need to be changed. So, rho 2 is equal to x by rho 1, x into rho 1. By what factor, density of the earth need to be changed to keep the g value constant? That's the question. So simple. The question is related to acceleration due to gravity and acceleration due to gravity and density. Immediately you should remember the formula related to acceleration due to gravity and density. So this indicates this formula. So g is directly proportional to r into rho. From here, g1 by g2 is equal to r1 by r2 into rho 1 by rho 2. Just substitute everything, you get the answer. G1 by G2. So G1 by G1, because G2 is G1, which is equal to R1 by R2. What is R2? 3 times R1. Okay. Into rho 1. Rho 1 divided by, what is rho 2 here? Rho 2 is x times rho 1. That x we need to find out. See here. This is what? R1 cancel, R1 rho 1, the rho 1 cancel here. What is remain? 1 is equal to, it's 1 by 3 into 1 by x. Okay, alright. So now this can be written as cross multiplication, 3x into 1. It is 3x which is equal to 1. So what is your x value? X value is 1 by 3. What is x? What is x here? By what factor density of the earth need to be changed? That's a x. Rho 2 is equal to 1 by 3 times of rho 1. So that's answer. By a factor of 1 by 3, the density of the planet need to be changed in order to get acceleration due to gravity remains same. Right? I hope you got it clear. So this is the very important concept for the NEET exam called acceleration due to gravity and density of a planet, the relation between them. Now let's continue further. What we had discussed already is, this is the surface of the earth. You can see it's the radius of the earth. From the surface at some depth, at some height, you can say, from the surface I am talking about, at some height, acceleration due to gravity is equal to G capital M by R plus H whole square. So this is the basic formula. Okay. At some depth, you can see here, at some depth. So what is the value at some depth? So G is suffix D, which is equal to G into 1 minus D by R. So this value also I am writing here. This is at some depth and this is at some, this is at some height and this is at some depth. G into 1 minus D by R. Look at here carefully. Let's concentrate on the depth. Here, I'm just writing this equation in this way. You can say G suffix D is equal to G into 1. So this is G suffix E. Okay. So G suffix E into 1, G suffix E minus G suffix E into D by R. Carefully go through the situation here. What is this? G suffix E is how much? 9.8 meter per second square. Yes or no? So acceleration due to gravity at some depth is equal to, this is 9.8 meter per second square minus something. Understand? So minus some value called x here. Carefully see here. So our aim is to find whether at some depth acceleration due to gravity is greater than 9.8 or less than 9.8. So here you get a solution. You can see here at some depth the value will be 9.8 minus something, that minus whatever it may be. However, the big value or small value. So 9.8 minus, that means you are subtracting something from this maximum value. So this value will be less than acceleration due to gravity on the surface. So what I can write? Acceleration due to gravity at some depth will always be lesser than acceleration due to gravity on the surface of the earth. I hope it's very clear for you. Now you concentrate on this part. Here also the same thing, right? Acceleration due to gravity at some height, which is equal to Gm, it's constant. Gm is constant, okay? So R plus H. So when this height is increasing, carefully see, when this height taken is increasing, the complete R plus H whole square value will be increases. So when the denominator is increasing and the final value will get decreases, yes or no? I'm writing here, when H value is increases, what happens? Automatically your R plus H square value also will get increases. When this denominator is increasing, your final value, acceleration due to gravity at some height will definitely decreases. Decreases of what? Decreases from what? Decreases from the surface value called 9.8. So that's the reason here also you can write acceleration due to gravity at some height is always less than acceleration due to gravity on the surface, right? The conclusion is the acceleration due to gravity will always have its maximum value on the surface of the earth, which is equal to 9.8 meter per second square. Remember, meter per second square. On the surface, always the value of acceleration due to gravity is maximum. Right? At any point it will be less than that, and most importantly you can see here at the surface it's 9.8, the value will be decreases and becomes a 0 at the center of the earth. In the same way, 9.8 is the value on the surface. So when we are moving to some height, decreases. At some point, you can say that's called infinite point. The acceleration due to gravity can be considered as 0 because it is decreasing. At some point, its value will be 0, similar to the center of the earth. Okay, clear? So this is what the conclusion of factors affecting the acceleration due to gravity. Okay, so shape of the earth, altitude means height taken, and the depth taken by the body from the surface towards the center of the earth. Okay, now how the questions will be asked based on this we have discussed time to time, but still the students will be commonly get confused while solving some kind of questions, and those kind of questions I am just going to explain to you. Listen to me carefully. So the question is, at what height, acceleration due to gravity will be 64% of the G value on the surface of the earth. So simple. So we know the radius of the earth is considered as 6,400 kilometers. They are given here. So simple question. At what height acceleration due to gravity will be 64% of the g value on the surface? Okay, what's the given data? What is the given data? Carefully see. Given data is acceleration due to gravity at some height which is 64% of the g value on the surface. So that I can write it as 64 by 100 of acceleration due to gravity on the surface. I hope it's very clear to you. 64% means 64 by 100 of the total acceleration due to gravity on the surface of the earth. So it's a given data. Now we need to find at what height it is happening. That's it. What is the formula behind acceleration due to gravity at some height, which is equal to acceleration due to gravity on the surface of the earth by r into r by r plus h whole square. Okay, substitute everything, you will get it. So acceleration due to gravity at some height is how much? 64 divided by 100 into g suffix e, which is equal to g suffix e into r by r plus h whole square. G suffix e cancel here. 64 by 100. This is square is there. Both sides, if we apply square root, these values will get decreased. Understand? 64 and 100 values are high. And this is square also is there. So to solve the values and the equations having squares, so it will be difficult for us. So we need to simplify the given statement or the given concept here. So that's the reason, to avoid this square, we need to apply square root on both sides. Then that will be 8 by 10. Square root 64 is 8, square root 100 is 10, which is equal to r by r plus h. So this is 2 4s and this is 2 5s. So 4r plus 4h, which is equal to 5r. Just cross multiplication. So this is the term I am keeping it here itself, 4 into small h, which is equal to 5r is keeping as it is right hand part, and left hand part is 4r. That 4r comes to the other side. 5r minus 4r, it is r. Okay. So from here what I can write, h is equal to r by 4. What is r? 6,400 kilometers by 4. 4 16. So what is the final answer? At 1600 kilometer, the acceleration due to gravity becomes 64% of the g value on the surface. Okay, so diagrammatically if you want, so listen here, this is the surface. Okay, so this is what the radius of the earth from the surface at a height called 1600 kilometer, the acceleration due to gravity will become 64% of the g value on the surface. So that's answer. Okay, now to make you confused, wantedly to make you incorrect, the questions can also be asked in this way. Listen to me carefully. Listen to me carefully. Same question, the answer is same, but the way of asking the questions will be different. Look at here. What's a way of asking the question to get to make you confused, right? What is that? You know, from the surface at some height, acceleration due to gravity is decreased to, you can see here, they decreased by, see, listen, from the surface, acceleration due to gravity is decreased at some height, acceleration due to gravity is decreased by 36%. Listen, decreased by 36%. What does it mean? Decreased by 36% means what is the final value present at this point? 64%. Again I am telling you, listen. The question is, at what height the acceleration due to gravity will be decreased by 36% of the g value on the surface of the earth? G value is decreased by 36% at this height. Decreased by 36% means what is remain? 64%. With the 64%, you have to solve the question in this way. So simple. Understand? You should not write 36 by 100. If they say that at that point 36% is there, the G value compared to the surface of the earth, you should take 36 by 100. If they say that the value of G at some height is decreased by 36%, means what is the final remained value to be taken here? Okay, clear? So in this way, the basic questions will be asked. Let's solve some more questions based on this. Let us solve two more problems related to this. Knowing that the mass of the moon is capital M by 81, where capital M is mass of the earth. Find the distance of the point from the moon where gravitational force due to the earth and the moon cancel each other. Here, there are two particles present here. One is moon and the one is earth. Imagine this is your moon whose mass is capital M by 81, and at some distance, so there is earth whose mass is capital M. Okay, so this is a moon and this is the earth. Now, given the distance between them is 60 times r, so this is 60 r. So it's a 60 r, right? Now, knowing that the mass of the moon is M by 81 and mass of the earth is M, find the distance of the point from the moon. From the moon, we need to find a distance where the gravitational force between these two will cancel each other. Cancel each other, immediately you should understand the point. They are asking about a null point. I hope it's very clear for you. They are asking about a null point. To find the null point, what you need to do it? So you need to recollect the previous concept. We need to keep a small test mass of small m. At a distance x, we need to keep it here. So this is what we are imagining as a null point at a distance x from the moon. It is at a distance x from the moon, means at a distance of 60r minus x from what? From the earth. Okay. So this is the point where the net gravitational force is 0. What is the net gravitational force? The force of attraction between these two masses will be equal to the force of attraction between these two masses. Understand? So let me write, this is the force of attraction between these two masses, and this F2 is the force of attraction between these two masses. So now what we need to do is F1 is equal to F2. So that's a condition for the null point. Yes or no? The force of attraction between these two is equal to force of attraction between these 2 points. So now what is F1? Tell me, what is F1 here? F1, we know the gravitational force formula, the basic formula we know. What is that? F is equal to G m1 m2 by r square. So F1 is equal to G, capital G, m1 m2. What is m1? It's capital M by 81 into m2. What is m2? Small m, divided by G m1 m2 by r square. What is r here? It is x. So it is x square, which is equal to here F2. What is F2? Capital G m1. So this is m1, small m, into m2. m2 is capital M divided by r square. What is r here? In between these two masses, r is 60r minus x whole square. What is our aim? Our aim is to find x. Okay, so capital G, capital M, small m, capital G, capital M, small m, cancels, right? So what is remained in the left hand side? Left hand side, what is remained? I am just writing here. What is that? 1 by 81 x square. Okay, 1 by 81 by x square. So this will be coming here, 1 by 81 x square, which is equal to 1 by 60r minus x whole square. Both sides, if you apply square root, it will be 1 by 9x. Okay, this is 9. Square root 81 is 9. Square root x square is x. So 1 by 9x is equal to 1 by 60r minus x. So from here what you can write, 60 into r minus x is equal to 9x. So from here what you can write, 60r is equal to, so 60r is equal to what? 9x. This minus x comes to the other side, minus x will be plus x here. So that is 10x. 0, 0 cancel. And what is your answer? Your answer, x is equal to 6r. Okay. So at a distance 6r, the null point will be found from the moon. So at a distance from the earth, how much? From the earth, it is 60r minus 6r. So I can say it is 56r. From the earth at a distance 54r. Right? 54r at a distance from the earth, there is a null point, and at a distance called 6r, there is a null point from the moon. In this way, questions will be asked. You should see the options. So as it is clearly given in the question, find the distance of the point from the moon where the gravitational force due to earth and moon cancel each other. From the moon, the answer is 6r. From the earth, the null point is at a distance 54 times r. Okay, like this questions will be asked. Now, let's see the last question of the session. What's the last question of the session? Spherical planet far out in a space has a mass. This is what the planet mass. Okay, and diameter of the planet is d0. Diameter of the planet is given and mass of the planet is given. A particle of mass small m is falling freely near the surface of this planet will experience an acceleration due to gravity is equal to acceleration due to gravity of a planet, they are asking. Okay, look at here. There is a small mass m is given. That's the mass of the body. This is given to confuse you, but you should be clear on the topic called acceleration due to gravity and its depending physical quantities, right? Acceleration due to gravity is what actually? It's capital G capital M by r square. Is there any dependency of acceleration due to gravity on the mass of the particle? No, right? That's what we had already discussed. Acceleration due to gravity is independent of the body mass. It depends only on the planet mass. Okay. So, you see the options here. All are acceleration due to gravities only. But this is the equation having no small m, body mass. But this is the equation is having body mass. That means, so this is incorrect. Because acceleration due to gravity is irrespective of the body mass. Here also the body mass is there. This is also wrong. Understand? In this way, while solving the objective questions, it will helps. Right? It's called conceptual learning. Here itself you can eliminate 2. Now, and do not guess the rest of the 2. So you should know how to find the answer. So this acceleration due to gravity, general formula is mass into g by r square. R is the radius. But in the given question, they have given us diameter. And right here, so diameter is equal to 2 times the radius. From here, radius is equal to diameter of the planet by 2. In the place of radius, you place this d0 by 2, you get the answer. So acceleration due to gravity of this planet, which is equal to g into mass of the planet divided by, so what's the radius here? So which is d0 by 2 whole square. So this I can write g m0 by d0 square divided by 4. Okay, so this 4 goes to the numerator. Your answer will be acceleration due to gravity of that planet will be, so this can be written as 4 into g into m0 by d0 whole square. So where is the option? You identified. So 4 into g m0 by d0 square. So this is the correct answer. Okay, it's a correct answer. So like this, numericals also will be asked. Hope it's very clear for you about acceleration due to gravity. In the next class, we will be discussing about Kepler's laws. right? So there are 3 Kepler's laws are available with us, which are also called as laws of planetary motion, right? At the end of the Kepler's laws, and I'll show you an interesting derivation which is connected to the first topic of gravitation chapter. Till then, see you in the next class.